Okay, hi students. When I left you in the last video, we were talking about co60, pardon me, and some of the photo peaks that it produces. And so I sort of have that running here, and you can see the characteristic double peak nature of cobalt-60. Again, this is 1.3 MeV, and that's about 1.1 MeV. You can look up the exact energies. But the problem with the equipment at the moment is we're not really using the full dynamic range of the MCA. In other words, all these channels here are just going vacant, but we should really fill them. We should always use all the capabilities of our device. So we need to get these peaks pulled over here, and I'm going to do that just by turning up the fine gain knob on the amplifier. So I'm going to reach down here. As I mentioned, this top knob here is the fine gain. So I'm just going to turn that clockwise to increase the amplifier gain a little bit over here. And so here I go. I'm going to turn it up a little bit. Turn it up a little bit more, and so I can sort of see some action here where the peaks are starting to rise. They are indeed shifting over to the right towards the higher channels because I'm increasing the overall voltage of everything going into the MCA. And maybe something like that. Let me just clear it again so we can sort of see clearly what's happening. Here we go. There's a little button up here right next to the traffic light. It looks like a graph with a slash line through it. That clears it. Hopefully you'll get to use the software someday on your own. And so here's the double peak of cobalt-60 coming in, 1.3 MeV there, 1.1. And that's about right. I'm not going to push it any further over. Maybe we could turn it up just a tad bit more, but I think we're doing okay. And maybe I will turn it up just a bit more like that, just get a peak over. So I did turn up a bit more. Let me clear it. Just to really use all those channels, right? Okay, so here we go. And so the reason why I'm doing this again is because in all the kits that we have to offer for radioactive samples, the cobalt-60 is the highest energy gamma ray we have. And so that means no matter what other source we put on the detector now, its spectrum is going to appear somewhere below the cobalt-60. All of the relative voltages coming in from the gamma ray energies will be lower. And so what we can do now is we absolutely promise ourselves not to touch the amplifier anymore. So we have it, the gain set kind of in a kind of an empirical way, just to park the highest energy gamma emitter we have over here and the highest bin numbers. And because everything else has a lower gamma ray energy, we're going to expect their peaks to appear over here. And so by promising not to touch the amplifier anymore, so we're literally can come over here, and if we're really going to be serious about this, even put a piece of blue painter's tape over the knobs if you want there. Just don't touch them anymore. So what that says is, like, no matter what, we know cobalt-60 is going to occupy these channels, everything else will fall in between, but by not touching the amplifier, we have some commonality in these channels here that will exist among all the sources we'll put on the detector. Cobalt-60 will appear about here, cesium-137 will be about here, sodium-22 will be here, as you'll see. So what I'm not going to do, say, is when I see the cesium-137 peak rise up over here, I'm not going to turn the amplifier gain up to move it over here to use all the channels just for that spectrum. I'm trying to get a common channel set for all of these gamma rays so I can get this x-axis calibrated into energy. So at the moment, the way it's running, it looks like channel about 950 corresponds to 1.3 MeV. It looks like over here, channel about, I don't know, 775 or so corresponds to 1.1 MeV. And let me take the cobalt-60 off, and let me put the cesium-137 back on. Here we go. So the cesium-137 is going back on. And so there, I am not going to turn the amplifier up to move this peak over. I'm going to leave it because now I have a couple of channel energy correspondences over here that I just sort of called out with the cobalt-60, and now it looks like channel about 505 or so is going to correspond to 663 keV. So you see what we're doing is we're building up a table of channel number versus gamma ray energy, and that will allow us to eventually have a fit function in a curve that will allow us to calibrate this channel axis into actual energy for the eventual graph required of this lab work. So here's what we're going to do next. I'm just going to make probably a couple videos here just cycling us through all of the sources that we have in the kit. And I'm going to save those in actual CSV data files for you to process, but take them and use them to calibrate this x-axis knowing that this amplifier was not touched. So there's a common amplifier gain setting among all of them. So the channels in one spectrum corresponds to the channels in another spectrum, even though the photo peaks will and should be all shifted around. Okay, so that's what the following videos will be. We're going to cycle through the sources.